G'day, it's Cliff here from Down Under. I've been getting a few emails and comments asking for information to do with these light lathes like Slant Pro 15L and Rapid Turn, to do with questions relating to tooling. So I've put together a video which is a continuation of my series on CNC turning tips and tricks, specifically about tooling, diamond lapping to get the best out of your tools, reaming, parting through difficult materials like stainless steel and high tensile steel. Alright, I'll get on with it. Cheers. Okay, I'm going to machine side 2 of the ITTP arbors. I'll run it with the door open and the coolant off. It's not ideal, but it shouldn't hurt to do it once. Facing, turn OD, ouch, those chips are hot. Ah, ow. Cut the thread now. Now we're going to bore the ID. Put in the center. Now we're going to face the internal ID with a internal facing tool. And finally, use a hand reamer to get the final ID precision reamed. Well, that was painful. I don't think I'll be doing that again. Anyway, let's just go through the tools. So the first tool was this Iscar Trigon tool. Really hard wearing tool. It's getting slightly dull and hence the chips are really hot. And then we went to a threading tool and I just diamond lapped that front face slightly. So that I didn't have an unnecessarily deep root on it. It's quite a good trick that. If you're using a universal threading tip, you can just lap the tip flat, a small amount if it suits the particular profile of thread that you want. Then I go to this very stiff diamond lapped inserted boring bar that's holding up really well. And finally, this facing tool, where are we? Down here. So that's a internal sort of reverse facing tool. And I leave the bore a couple of thou small, 1 or 2 thou small, and run a hand reamer through. And unlike my other video where I was talking about blind reaming with a machine reamer, if you're going to pass right through, it's a good idea to use a hand reamer, because a hand reamer has a very shallow lead in and the tool is unlikely to cut oversize. It will spring into position and just cut the size of the reamer. You still want to have it fairly concentric, but you can have a very high feed rate and a low RPM, and it will just scrape out that final couple of thou or 1 thou, even half a thou, and give you a beautiful finish. Well, that's the ITTP arbor there now, all ready for heat treatment and cylindrical grinding. I think I will change that little carbide insert round to a new edge. It's done a whole bin full of chips, so it's time to give it a new edge. But have a look at that beautiful finish in there from the hand reamer. Beautiful, like a lapped finish. It's still got a little bit of metal on because it's still got to be cylindrically ground, but I'm really pleased with that part. I probably don't need to strive for perfection where you're grinding after heat treatment anyway, but I just enjoy it. So this is the final part after it's been cylindrically ground. So that diameter is ground and the face is ground, and obviously the 3/4 inch diameter is precision ground, and that TTS face is ground, and that gives an exact right angle. It generates an exact right angle. So that's the completed arbor there, and that's it just coming off the lathe now. When I talk about diamond lapping, I'm referring to these hand laps most of you will be familiar with. This red one is a fine. You can use a fine that's been used for a while, or a super fine is better still. And just use your red one for roughing, and when it gets blunt it becomes effectively a super fine, and you can lap the edges on your tungsten carbide and high-speed steel tool bits to modify them slightly and sharpen them. This is probably one of the most important tools that I have are my diamond laps. So the blue one is the super fine, and that's about right when it's new. A red one is good for coarse work, for roughing out, and as it becomes dull it becomes a super fine after a while. So these last for years, and just dip them in a little bit of kerosene, and if you don't know about these, I highly recommend them. They are a game changer for many situations. I've had a few people ask me over the years how to part successfully. I've just had an email now, and something I've neglected to go over in detail. So I can't stress enough the importance of going narrow. The blade must be narrow for these light machines like the Slant Pro 15L and Rapid Turn. You can't use a 3 or 4 millimeter wide blade. You will be right on the edge of possible and not possible. The tendency to chatter and vibrate is too high. Once you get down to 2 millimeters, it becomes a lot more doable. You can part off tough high tensile steel and stainless steel with a 2 millimeter blade. So this is my there's several different brands, and you know I'm going to promote this one because I know it works, but I'm sure it's not brand dependent. As long as you get a good quality industrial brand. This is an ISCAR SGF 26-2. You need enough depth to give you stiffness, and just project it the absolute minimum for your particular job. If it's a 40 mil diameter piece of high tensile steel, just project it out that radius plus 1 or 2 millimeters clearance. So you want the maximum stiffness in there. So the tips are very sharp. If they're unplated, they're even sharper, because when they plate them, it puts a small radius on the edge, and you get a higher inclination to chatter. So an unplated tip is probably best. This ISCAR holder takes a GFN 2J IC328 tip for a general purpose steel and aluminium tip. Find it works very well. It collapses the chip down so that it doesn't jam and weld up inside the slot. I'm sure there are other good brands like Sandvik and Kennametal and so on, and they probably work equally well, but I've been sticking to this type of blade, the ISCAR SGFH 26-2, and they are absolutely brilliant. a tool like this is just too wide for these light lathes. So the trick is go narrow. It's really worth the investment, and you'll be able to part off with no problems. The tool must be held rigidly, well bolted in a good fitting block so that it's not vibrating. That's also very important. They're so good, these 2mm blades. I've got one for each of my lathes. This is the one for the big lathe, and even for big work I use it. Why go wider than you need to? These 2mm deep blades are strong, rigid. You can cut through large diameter, high tensile steel parts. They're interchangeable for me between the different machines because they're all the same tips. So I use them on this big lathe, on my small manual lathe, and I use them on my Slant Pro 15L and rapid turn. Very seldom have I had a disaster or a broken blade. In recent years they've been rock solid. Okay, what about speeds and feeds? Well, if you're parting through stainless steel and high tensile steel, you want to be pretty gentle. You've not got a high powered machine, so just be conservative. It doesn't take very long because you're only parting the radius. Have a good flow of coolant, run your job slow RPM and a very light cut. If you want specifics, constant surface speed of about 50 meters a minute and a depth of cut of 0.075 millimeters or about 3 thou. But just run it slow, take it light, have a bit of a peck on it every 2 or 3 millimeters so you get nice little rolls of chips coming out. And these new design tools collapse the chip in narrower than the width of the groove, and you shouldn't have any trouble with that little roll of chips welding into the groove. Thanks for watching, guys. Catch you next time.